evaluate expressions. So evaluate, all evaluate means is find the answer to. Find the answer, right? It's when we put an equal sign to an expression. So let's just go over something. If I said 12 minus 2, right, it's 12, that's an expression, right? So if we wanted to evaluate that, we just put an equal sign, and there it is. We just evaluated it. We found the answer. So when we evaluate expressions, we also need to remember GEMDIS, right? So I'll bring this up here. GEMDIS, which we also call PEMDIS, which we know about. It's the order of operation, so you got to keep that in mind. So we have the grouping symbols, right? We remember we have the brace. There's the brace. We also have a bracket, and we're all familiar with parentheses. The grouping symbols. Exponents, multiplication or division, remember whatever comes first, and addition or subtraction, they're linked together also, whatever comes first. GEMDIS, PEMDIS, however you want to do it. So let's try one. So what if I wrote 25 minus this? So how would we say this? Right? So here we have what? That's the difference. Oops. There we go. This is the difference of 8 and 7, right? We could say 25 minus the difference of 8 and 7. Right, so let's evaluate it now. Evaluate means let's find the answer. Let's put an equal sign. So we should do parentheses first. So we'll do 25 minus 1. And our answer will be 24. Right? Great. Let's do another one. So if I said 8 less than 5. No, not 5. 9. 8 less than 9. Right? A little blurry end there. Okay? So there's the expression. Who remembers less than? What we have to do with less than? Got to flip it around. So this would be 9 minus 8. And then we evaluate with the equal sign. There we go, right? Okay, let's do our third problem. So if you, again, the word evaluate means to solve. It means to solve it, right? So if we have 4 times 20 minus 9, what is the expression, first of all? Well, again, with the parentheses, we could say the difference of 20 and 9 multiplied by 4. So we got to do parentheses first, so we'll bring the 4 down. 4 times, we can also use the dot, right? We can also put a dot there, whatever you're comfortable with right now. And what's 20 minus 9? 11, right? Then we do 4 times 11, and we evaluated and we got 44 as our answer. So let's do some word problems with that. Okay, here's our word problem. Let's read it. Larry is 6 years old, so we know that. His brother Hank is 1 year younger than double Larry's age. So write an expression and then tell me what the answer is. Evaluate it. So first we should look at what Hank is. He's 1 year younger than what? He's 1 year younger than double Larry's age. Right? He's not 1 year younger than Larry. He's 1 year younger than double his age. What's double mean? Multiplication, right? Double 6 is 12. So we know that it's just 12 minus 1. We know that Larry should be 11. Right? Because he's 1 year younger, that's minus, 1 year younger than double this. When you double 6, you get 12. But we can also write an expression this way. Get that 44 out of there. So we can say that double means we can put 2. 2 times 6 is 2 times 6. By the way, that's how you can write multiplication. You can write it that way with a parenthesis sign. That means 2 times 6. Or we can just do it the normal way, if there is a normal way. 2 times 6. right? He's going to be this minus 1, right? And you can put parentheses around. You don't have to. It just looks nice to put it. He's double Larry's age minus 1. And he's 11. Great job. Let's do another. What is going on today? All right. Jack has $25. Jack's big music show. He spends 14. Spends. What do you think that means? You spend, it's a minus, right? Spends 14. Then he earns double. You remember what double is already, right? What's double? Multiplication, right? Double what he had in the beginning. What did he have in the beginning? He had 25, right? So what is he left with? What is he left with? Evaluate that. Be careful with the word then. Then means something happens next, right? So there's going to be a parenthesis in here. So let's do this, right? I'll get rid of this. All clean. There we go. So we know Jack had 25 to begin with, and he spent $14. That's what he did. We have to put that in parentheses because he did that first. If we didn't put the parentheses, order of operations is going to make us do other things. Because it says right here, then he did something else. He earns double. He got something. He got double doing something. We don't know what he's doing. Maybe he mowed the lawn, did his chores. It's going to double what he had in the beginning. So this is going to be added to what he next gets. He's going to double what he had in the beginning. Right? So first he did this. Then he earns this. So what is he left with? We have to add them together, right? So over here we have an 11 plus 50. And he's left, what does he have now in his pocket or his piggy bank, whatever? He has what? $61. Now you should understand why we put parentheses around here, because this is what he has to do first. Okay, let's look at another problem. So who remembers what this is? If I said that, how do you write that expression in English? That's a third of a number, right? That's a third of a number. You can also write it like this: 1/3 of 12. You can write it like that. It's the same thing. 1/3 of 12. You're dividing, right? Put the top number, the numerator, in the box. We know we get 4. Or we can multiply this whole thing. 3 goes into 3 once. 3 goes into 12 4 times. You get 4 over 1. Bring that up there. There you go. 4 over 1, which is 4. So that was a third of a number. So this is a fifth of a number. A fifth of 15, right? We know that's 3. So let's say we had this. You had this question. All right. What is the expression? Well, what is this? This is a fourth of 20 added to the sum of 3 and 2. So let's evaluate this. What would this answer be? Well, this is going to be 5, and that's 5. The answer would be 10. Great. Okay, let's look at a division problem. Let's say we're on a train, right? You're on a choo-choo. Right, we're on this train here, right? There we go. Old train set. Let's say that the train holds, let's say it holds 250 people. And then it has cars on the train. So each train has sections, right? Here's a bad train, but you know what it is. These are cars, right? So let's say there are 5 cars on the train. And they have the same amount of seats. So how many seats does this train have? Well, this would be a division problem, right? And how do we write the expression? So let's bring this up here. All it is 250 divided by 5. So what would that answer be? Well, that means there's 50 people in each car. So let's say now that at the first stop, 102 people get off the train. So how do we write an expression now to say who's left on the train? How will we write that expression and then evaluate it? All right, let's erase this. So we know the train has 250 people, has 5 cars, there's 50 people in each car. So we should know this, that there's 250 people. That's what we care about. We know there's 250 people. We don't care how much are in each car, but we know then that 102 people get off the train so we're just subtracting, right? And if we evaluate that, what would that answer be? Right, so if we evaluate this, it'll be 148. Okay, so evaluation is just trying to find the answer to an expression. Great job.